In this video, we're going to solve equations with exponents. Let me give you an example, of what we'll be kind of working through. So this first example here, x squared equals 36. So I could probably figure out what x is, right? If I think about it, what squared gives me 36? Well, x equaling 6 would work, right? Plugging in 6 and squaring that will be 36, but also -6 works too, right? Because if I square -6, the two negatives become positive and it's a 36. So technically, both work. And we want a way of kind of thinking about this so that I could solve these equations as they become more complicated. And what we'll be doing is introducing a radical, or in this case, we're calling it a root because we're basing it on square root, cube root, and so forth. Okay. So they call it the root property, but we are talking about radicals. So what we'll be doing is thinking of this in terms of odd and even. So if I have an equation, x to the n equals b, where n happens to be an odd number, then I would solve by taking the nth root of b. And that works for even problems as well. But there is a difference, and I just kind of pointed it out because up here I had an even answer, and I'm sorry, an even exponent, and that ended up getting a positive answer and a negative answer that could work. So when I do an even number or an even root, that means I actually have a positive and negative possibility. So let me come back up to this problem and use this idea here so you can kind of see what that's going to look like. So when I want to solve this, what I'm going to do then is I'm going to, oops, I switched to green, but it didn't catch up yet. Let's do that again. There we go. I'm going to square root both sides. And what that means then on the left side, the x and the x squared, just like in our last section, kind of cancel out. They undo each other. And I'm left with x. And on the right side, the square root of 36 is 6. But because this is an even power, that means that both positive 6 and -6 can work. So this would be like the short way of writing +6 and -6 with the plus or minus in front like this. And that's perfectly reasonable for doing these problems. You'd be okay to put the plus or minus in your answers. Now on my open math, they're going to probably have you put them separately with a comma. So you'll probably have to put like -6, comma 6 as your final answer. But on like an exam, this would be reasonable to put the plus or minus like that. Okay, so this is probably how we'll do the answer in mom. Okay, let's go ahead and try another one. So for this one, I am going to I'm going to rewrite it, and I'm going to take the cube root of both sides. So I'm doing the root based on the exponent that I'm trying to get rid of. Because remember, when we're solving, our goal is to get the variable by itself. So I'm trying to get rid of the cube, and the way I can get rid of it is to take a cube root. Both sides though. So on the left side, this just becomes a y. And on the right side, I need to actually take the cube root of -8. So what times itself 3 times gives us -8? Well, that's -2, because -2 times -2 times -2 is -8. The fact that there's an odd number gives me the negative. And I don't have to worry about a plus or minus. And the reason I don't have to worry about a plus or minus is because it's an odd root and an odd power. So I only have to worry about plus or minus whenever I'm working with even powers and even roots. Okay, so let's go ahead and look at this next one here. So when I want to solve this, I see that on the left side, I have something squared equals 49. I can use the root property to do this. So I'm actually going to squeeze it in rather than rewrite it. I'm going to go ahead and square root both sides. So on the left side, that just becomes x plus 1. And on the right side, the square root of 49 is 7. However, it was an even root. So technically, it's plus or minus 7. There's a positive 7 and a negative 7. So really, I have two equations. I have x plus 1 equals positive 7, and x plus 1 equals negative 7. And these are the two equations I'm going to solve for x. So if I subtract 1, that's going to give me x equals 6. Over here, subtracting 1 is going to give me x equals negative 8. And we can check our answers, make sure they work. We don't have to stress so much about it in these, though, because we aren't starting with a radical to begin with, so we don't have so many restrictions on what we're allowed to plug in or get out. So when I plug in 6 plus 1 is going to be 7. And 7 squared is going to be 49. It's going to work. Yay. Okay. When I plug in 8, that'll be, I'm sorry, negative 8. Negative 8 plus 1 is going to be negative 7. And negative 7 squared is 49. Okay. So they both work. I'm not going to go through the checking on these, though, like I did in the last section. Like I said, we don't have to worry so much about having issues with our answers because we're not having a radical in the original problem. The original problem, is something that's with an exponent, and negatives aren't a problem when we have exponents. I'm not stressed about those. Okay, let's try this next one here. I'm going to take the square root of both sides. Here, this is kind of a little bit low. All right, I'm going to take the square root of both sides, and that's going to give me a 2x plus 3 on the left and a plus or minus 9 on the right, since we're doing an even power, even root, a square root. Okay, so now I have two equations. 2x plus 3 equals positive 9, and 2x plus 3 equals negative 9. Okay, so I'm going to minus 3, which is going to be 6, and divide by 2, which will give me x equals 3. Over here, I minus 3, which will give me negative 12. Divide by 2, which will give me x equals negative 6. And I can, of course, double check to make sure that those work. All right, let's try another one. All right, so let's go back to a cube. So I can do this. I just have to take the cube root of both sides, the cube root. On the left side, I have x plus 4, because it cancels that out. But on the right side, I'm going to have the cube root of 125. So what cubed gives us 125? Well, the answer is 5. 5 cubed, or 5 times 5 times 5 is 125. All right, so that's going to be then and I don't have a plus or minus on this one, right? Because it's just, it's an odd power. So I'm just going to minus 4 and get x equals 1. Okay, let's try another one. So for this one, I want to go ahead and isolate the squared, kind of like how we did in the previous section, because I want it so that when I take the square root, the square is going to go away. If I try to take the square root with the plus 6 there, that's not going to work. I can't take the square root with a plus. It's not going to go away. That plus 6 ruins it. So I'm going to minus the 6 first, which will give me 6 plus 1 squared equals 4. Now I will take the square root of both sides. So the left side, I'm going to get 6 plus 1. And on the right side, that's going to give me plus or minus 2. Okay, so two equations. 6x plus 1 equals 2. 6x plus 1 equals negative 2. And we're going to solve those both. So that's going to be, let's see, minusing 1. 6x equals 1, dividing by 6. So I'm going to get a fraction. That's fine. 1/6. Over here, when I minus 1, that's going to give me negative 3, dividing by 6. So that reduces to negative 1/2. And I'm fine that there's a fraction. That's not concerning at all. Okay, so let's try another one. This one, I don't have to isolate it. It's already ready to go. However, when I take the square root of both sides, the square root of 20 isn't like a perfect square. So I'm going to have to break this up and simplify the square root of 20. So here, I'm going to do that over here. There's a couple ways to do this. The way I like to do it is I like to break it into two numbers where one of the numbers happens to be an actual perfect square. So 20 is 4 times 5, and I can take the square root of 4. The square root of 4 happens to be 2. But 5, I can't take the square root of, so it's going to stay inside. So I'm going to come back over to my problem here, and when I take the square root of the left side, I get 3x plus 2, but on the right side, I get plus or minus 2 radical 5. So on this one, if I break it up into the two equations, and I try to solve for x, we're not going to actually be able to do all that much simplifying. And the reason is that radical 5 is going to kind of ruin it. So when I go to subtract 2, I can't. I'll end up getting 3x equals negative 2 plus 2 radical 5. Like I can't add those together. And then dividing by 3, I can't. Like that's going to be the answer. Negative 2 plus or minus 2 radical 5 over 3. And over here, it's going to work like exactly the same, except it has a negative. Negative 2 minus 2 radical 5 divided by 3. Okay, so they end up being exactly the same, but with a negative and a positive in the middle. Some answers on Mom might have you enter them separately. Sometimes they have it formatted so that you could treat it like a plus or minus. In other words, if this was just being written down on paper, from here, from this part of the problem, I probably wouldn't have bothered breaking it up into two different equations because they're both not going to simplify. So I would have just minused 2 from both sides and just said negative 2 plus or minus 2 square root of 5. Divide by 3, divide by 3. So x equals negative 2 plus or minus 2 radical 5 over 3. And this is the same as these two. It's just broken up into a positive case and a negative case. So it works either way. Okay, so let's look at a higher exponent. So I know we're not as comfortable working with some of these higher exponents and higher radicals, which is why I wanted to take a moment to do that. And then we're going to talk about some of the cube roots and fourth roots and so forth. So if I wanted to get rid of the 4, I'm going to have to take the fourth root of both sides. I should probably just rewrite it. That looks terrible. Okay, take a second. Let me rewrite it. So that's going to be x to the 4 equals 81. And I'm going to take the fourth root of both sides. So on the left side, that's just going to be an x. On the right side, when you multiply it by itself 4 times is going to be 81, and the answer is 3. And I do have to put a plus or minus because it's an even problem. Okay, so real quick, let's go through the perfect squares you're kind of expected to know. Most of us are very comfortable with the perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, gave you like the answer. But I do expect you to know beyond that. You guys should know more. So 11 squared is 121, 12 squared is 144. You sometimes see 13 squared, but I won't really expect you to know that. 13 squared, by the way, is 169. And really, they just kind of start looking at multiples of the perfect squares beyond that point. So those are kind of the big ones you're expected to know. I expect you to know that when you take the square root of 4 here, right, you see a 4, that it's going to be 2 squared, right? It's square root of 4 is 2. Or when you see a square or 49, that's going to be a 7, right? Because 7 squared is 49. All right, so these are the perfect square numbers. Well, it works for cubes. And those are the ones I kind of want you to know so that you're ready to go for the class. So the perfect cubes, you are expected to know. Okay, so similarly, 1 cubed is 1. 2 cubed is 8, so that's a perfect cube that I expect you to know. 3 cubed is 27. You should know that one. 4 cubed is 64. 5 cubed is 125. And actually, beyond that, the only other one I really want you to know is 10 cubed. And 10 cubed is 1000. So I'm not expecting you to remember as many cubes. These are really the ones you should know. That if you see a 27 and you're asked to take the cube root of 27, that's 3, right? So 3 cubed is 27, and 4 cubed, and so forth. So this is 10 cubed. That's one that's different. Okay. All right. So for fourths, there's even less. There's even less I'm expecting you to know. For and we could call them perfect fours if you want. Perfect fourths. They get unoriginal as you get higher up. So 1, 2 to the fourth is 16. 3 to the fourth is 81, and that's it. Those are the ones I'm going to expect you to know. Or 10 to the fourth, that's 10,000. Sure, you might know that. But those are the big three. Really, those are the ones I'm expecting. Fifths are even less here. I'll squeeze it in right below. Perfect fifths. So for that, you should know 1 and 2, which is 32. And honestly, that's the highest I would really expect you to know. Okay. So these are the numbers you're going to kind of see a lot in the homework, and you'll get practice with them when you're taking cube roots or square roots. You'll start to see these numbers. They'll pop up more and more. But these are really what you're expected to kind of have known in your mind, though you're not going to be without a calculator. It's just to kind of know so that you're prepared and not taken back by them.